Bismillahirrahmanirrahim. Dear viewers, now we are going to do analysis in Dlubal Rfem software. We wanted to show the application of earthquake load, but as we are using this trial version, that's why the earthquake or seismic load generation is not working here. I will show you. Go to add-on modules. To generate the equivalent earthquake static load or seismic static load, you have to use RF Dynam Pro. Here, natural vibration, you can activate mesh combination, and for our equivalent load we need to click on this, but here it is showing the add-on module. Dynam Pro equivalent loads work only as a demo version without authorization. So as we have not a license, so we cannot use this one. Only we can analyze the vibration and we can see the deflections. Mesh combination, here also it will not allow. So these two we can check. Mesh cases, we will select MC1 and then we will use the mesh from self weight of the structure. For the seismic load, calculate meshes. It will calculate the mesh and the center of total mesh coordinate. Then mesh combination, we select MC1, then this one, and natural vibration cases, this MC1, and here the settings and scaling of mode shapes, calculation parameters, this one, and in direction XYZ, type of mesh matrix. Here you can choose according to the requirement of the analysis, and method of solving eigenvalue problem. Here 4 options, and edit, you can edit mesh settings. I am not going for that one. We can click on OK and calculate. Here this is the natural vibration effect on the structure, Ux, Uy, Uz, phi x, phi y, phi z. Here it is showing the deflection, and if you don't want to see the display mesh, then it will be like this. Now as we cannot generate the load cases for earthquake, only we can see the deflection. So let's go to load combination. Here edit load case and combination. Here action, live, dead, live, group, live, wind. These 4 type of load we have generated or created. Combination this as per the ACI 31814. Action combination, load combination, it is generated automatically by the program. And this is our result combination. Okay, now we will go for calculate all. After the analysis, it will show the analysis result. like this. This is the animation. We can change the display property for node. We can check member stresses also. You can check the support reaction also. For different load combination, you can check the reaction loads. And we can check the frame SFD BMD internal forces. This normal or axial load. This is VI. This is VZ. This is MT, torsional moment. This is MY. So this is our SFD PMT diagram from our members, and now we can go for design. For design, you have to go to design concrete, RF concrete member for beam, RF concrete column for column. First we can go for column. General data, this design code, ACI, this one, and the strength limit state. We will select all. Only we can deselect single load cases, and we will select the member. Okay, now material, this is the concrete strength, and reinforcement steel strength grade 60, cross section this 12 by 15. The section available in the model, this is showing here. Reinforcement, we will write column. We will select 5 and 6 number of bar. If we want to provide different arrangement, we can provide uniformly surrounding. We will choose, and tie and stirrup number 3 bar. Secondary reinforcement, if you want to consider, you can consider it. Okay, now calculate. After the design, it will show the result. Here different number of members showing the result. This member number here it will show by the arrow. Here you can see the longitudinal reinforcement required and tie or stirrups. Shear reinforcement is still schedule. So in this way we can design column and the required reinforcement. Required reinforcement is longitudinal, and for shear this one. This is the required reinforcement for columns. Here you can see the intermediate results. Here is the reinforcement rendering for columns. So from the module we can check and change the member type. Here this member 1 it is passing, ratio is 0.783 below 1, so it is passed. We can filter the result greater than 1, this one, we can change the cross section and we can get the design ratio below 1. So in this way we can design our column, and in the same way we can design our beams also. So for slab design we can go to add-on module, surfaces. This strength limit is set. Press shift, then select control, and this like this one. And for serviceability we will select the ASD dot combination. Okay, material, this is strength, surface, this is the surfaces, reinforcement we can write slab, reinforcement layout, refer concrete cover to centroid of, you can provide edge, and this is the concrete cover, longitudinal reinforcement, use required reinforcement for design of serviceability. Minimum reinforcement should be provided. Design method optimization of design internal forces. So calculate. So after the calculation by surface you can see the required reinforcement. Serviceability design, so it is passed for deflection and deformation. And now we can go for graphics. Required reinforcement, this is the shear reinforcement, design internal force. This is our design internal forces for serviceability limit state design. This is for cracked width. So in this way we can design column, beam and slab in Dlubal Rfem, and if we have a license for the software, then we can generate seismic load also. So till up to this I have tried my best to show the capability of the software, and for the lack of the license I could not show the seismic load generation. So I hope it will help you to grow interest on this software, and you can have the idea of analysis and design on this software. So thanks for watching, and stay tuned for more tutorials.
Press the bell icon on the YouTube app and never miss another update.